Good morning, all. Today we are going to discuss the topic Archimedes principle or the story behind Archimedes principle. We all know that the Archimedes principle states that the upward buoyancy force that is exerted on a body immersed in a liquid, whether partially or fully submerged, is equal to the weight of the body that the body displaces and acts in the upward direction at the center of mass of the displaced fluid. So, today we are going to discuss about the story behind Archimedes principle. Archimedes was possibly the world's greatest scientist, at least the greatest in the classical age. He was a physicist, mathematician, astronomer, inventor, and engineer. Many of his inventions, theories, and concepts are still used today. Perhaps his best known achievement was his Eureka moment when he discovered the principle of buoyancy or Archimedes principle. For others, Archimedes has gone down in the history as a guy who ran naked through the street of Squares to Eureka, shouting Eureka, or have it in Greek. The story behind that even was that Archimedes was charged with proving that a new crown made for Hieron, the king of Sarras, was not pure gold as the goldsmith had claimed. The story was first written down in the 1st century BC by the Vitruvius, a Roman architect. Archimedes thought long and hard but could not find a method for proving that the crown was not solid gold. Soon after, he filled a bathtub and noticed that water spilled over the edge as he got in, and he realized that the water displaced by his body was equal to the weight of his body. Knowing that the gold was heavier than other metal, the crown maker could have substituted in. Archimedes had his method to determine that the crown was not pure gold. Forgetting that he was undressed, he went running naked down the street from his home to the king, shouting Eureka. Archimedes' principle is very useful for calculating the volume of an object that does not have a regular shape. The oddly shaped object can be submerged, and the volume of the fluid displaced is equal to the volume of the object. It can also be used in calculating the density or specific gravity of an object. For example, for an object denser than water, the object can be weighed in air, then weighed when submerged in water. When the object is submerged, it weighs less because of the buoyant force pushing upward. The object's specific gravity is then the object's weight in air divided by how much weight of the object loses when placed in a water. But most importantly, the principle describes the behavior of any body in any fluid, whether it is a ship in a water or a balloon in air. Thank you.